So hello guys, in this video we are going to solve this problem. So in this problem it is given that for any complex number w which is c plus iota d, let the argument of w lies between minus pi to pi where minus pi is not included and iota is root of minus 1, and let alpha and beta real numbers such that for all complex numbers z which is x plus iota y, they satisfy this property. So alpha and beta are real number and z is a complex number which is x plus iota y, and they satisfy this property. Argument of z plus alpha divided by z plus beta is equal to pi by 4, and this x plus iota y we have complex number, so this x comma y pair lie on this circle. So x and y coordinates satisfy this property, they lie on this circle. Then we have to tell which options are true based on the values of alpha and beta. So this is a multiple choice problem. So you first of all find out the value of alpha and beta, and based on that you have to tell which options are true. So let's see how we can do this. So first of all, in the problem it is given that argument of this thing is pi by 4, and now you see in the problem it is given that the x comma y lies on this circle. So if you see, the center of the circle is minus 5 by 2 comma 3 by 2. So the in the complex form, if we write like we know z is x plus iota y, so the center of the circle is this. So the z naught will become in this form, like minus 5 by 2 plus 3 by 2 times iota. So this is the center of the circle we know. Now you see this z lie on the circle, and this satisfies this property, like argument of z plus alpha divided by z plus beta is equal to pi by 4. So this is the let's say this is minus beta which is also lying on the circle, and this is minus alpha which is also lying on the circle, and this argument of z plus alpha which is this line, and argument of z plus beta which is this line. So the angle between these two lines is pi by 4, like this angle. You see this angle which is pi by 4, so it is given in the problem. And now you see the center of the circle is this. So this minus beta point is here and minus alpha point is here, and this is the one chord that joining them. So this chord is making an angle pi by 4 at the point z here. So we know by the circle property, at the center the same chord will make an angle of pi by 2. So this is the circle property. So by using this property we can write like the argument of z naught plus alpha divided by z naught plus beta is equal to pi by 2. If in the problem it is given that this argument is pi by 4, then using the circle property we can say that this argument in which the center of the circle is involved, this argument is pi by 2. And we know if the angle between this line and this line is pi by 2, then we can write the z naught plus alpha is iota times z naught plus beta because of this angle. It is the rotation by an angle of 90 degrees, so you just multiply this z naught plus beta by iota, so this is equivalent to this z naught plus alpha. So this is the meaning of this property, like argument of z naught plus alpha divided by z naught plus beta. So this argument is pi by 2. So the meaning of this is this z naught plus beta, which is this line, you multiply this by this iota, and this is equivalent to this z naught plus alpha. So this is the meaning of rotation by 90-degree angle. So you see this line we are rotating by 90 degree. So it is just equivalent to multiply by iota. So here if you have some number like this 5, then if you rotate by 90, then it will become like 5 times iota. So just multiply by iota. So from here we can say that z naught plus alpha is equal to iota times z naught plus iota times beta, and we can take this iota times z naught to the left hand side and this alpha to the right hand side. So this will come in this form, like z naught multiplied by 1 minus iota is equal to iota times beta and minus alpha. Now we know the z naught, which is the center of the circle. We initially calculated it is minus 5 by 2 plus iota times 3 by 2. So we can put that here, and this is multiplied by 1 minus iota, and this is equal to this. So first of all you multiply by 1, So it will become like minus 5 by 2 plus iota times 3 by 2, and if you multiply by minus iota it will become like 5 by 2 times iota and plus 3 by 2. So now you see this will give us minus 1 and this will give us plus 4 iota, and it is equal to iota times beta minus alpha. So this is this. So from here we see that alpha and beta are real numbers, so we can they don't have the complex part, so they are only real numbers. So if they are only real number, then we can directly compare this alpha with this real part and this iota times beta with this 4 times I. So from here we can get the value of alpha and beta as alpha is equal to 1 and beta is equal to 4. Because we know alpha and beta are real number, so we can directly compare the real and imaginary part, and directly we can get the value of alpha and beta. So now we know the values of alpha and beta. So now we have this alpha and beta, so we can directly tell that which options are true. So based on a value of alpha and beta, this option is true. Alpha and beta is product is 4 and beta value is 4. So these two options are correct, B and D, and in this way we can solve this problem. And you can also see that this alpha and beta are also lying on this circle. So we know the alpha value is 1 and beta value is 4. And here we have the coordinate is minus beta and minus alpha, which are lying on the circle. So both are real number. So if you put alpha and beta values in this circle equation, they also satisfy. Like we know alpha is equal to 1, so alpha is so minus alpha will become like minus 1. So if you put minus 1 in this, so it will come like this minus 1 is square, y coordinate is 0, and plus 5 times minus 1, and y coordinate is 0, and this plus 4. So this will giving us 0. So this is also satisfying this equation. And if you put like minus 4, so it will become like minus 4 square plus 5 times minus 4 and plus 4. Y coordinate will become 0. So this is also 0. So both minus alpha and minus beta are also lying on this circle, and in this way we can solve this problem.